Assalamualaikum and good day to Dr. Erwan Hafizi bin Kasiman. My name is Akmal Shukri bin Muhammad Noor. Today, I would like to present a major part for Integrated Design Project 1, which is Water Reticulation System. Here is the content of this slide, which is Introduction, Project Description, Design Criteria, Design Analysis, Water Tank Design, and also the conclusion. For introduction, water reticulation system is the water distribution network that exists within every advanced societal framework. Planning and designing a feedlot of water reticulation system depends on its access to water, location, size, site, and the operation. Objective of the water reticulation system is to ensure the minimum residual pressure head are satisfied. Second one, ensure the layout, pipe size, and pump capacity of the system can efficiently supply. Allow excess maintenance to pipe, valve, and pump. And the last one, to obtain the flow rate of each pipe. For the project description, this project is located at Ulu Tiram, Johor Bahru. They are mostly light industry cluster and the others are twin light industry, cluster service industry, core service industry, and a few double chamber. We decided to design the pipe using closed loop pipe network. After we decide, we conclude that there will be a total of 42 pipes, 30 of node, 12 of loop, and a 40 for fire hydrant. All the water supply designation is referred to the guideline and specification of water supply reticulation in Malaysia, which is Suruhanjaya Perkhidmatan Air Negara (SPAN). For design criteria for pipe network system have a two type, which are network are closed loop pipe, network of dead end pipes. We shall employ a closed loop pipe. All of the pipes are connected. There are no dead ends in the system. Water can come from a variety of direction to reach a given point of withdrawal. Design criteria for water demand is the information on the development water supply needs presented in terms of total daily demand. According to SPAN, these are estimated based on the field layout plan, proposed form of physical development, and unit rates demand by various type of premises. Here is the table taken from SPAN table B1. In this project, mostly we use building for light industry, low cost terrace house or low cost flat, and others. Design criteria for average water demand. Average water demand is the amount of water that the treatment plant must produce in order to meet all of the community's water needs. Is known as system water demand. Water demand includes water delivered to the system to fulfill consumer needs, water supply for fire extinguisher and system flushing, and water needed to run the treatment plants correctly. The total storage capacity in the tank per day is determine the average flow rates in the pipe approaching to each tank. Design criteria for peak flow rate. The goal of peak flow rate is to design a pipe that approaches domestic storage water tank, and on this calculation does not include firefighting flow and its flow to hydrant. Here is the table taken from the SPAN that the peak flow rate we use urban and rural areas, which is 2.5. Design criteria for firefighting flow. The flow rate in firefighting pipe is equal to the flow equivalent to the number of hydrant used concurrently. Meanwhile, the flow rate in the domestic water pipe is the same the average flow rate. The fire flow rate used in this project are derived using the average flow rate plus the hydrant flow of the specific node depending on the type of fire risk. In this project, we use Class A risk. Design criteria for pressure head at the water mains. The minimum available pressure head at the water mains should be determined from the local water authority before designing the distribution pipeline from the water mains to the rise of water tank. The minimum available pressure head will be provided to the designer when the local water authority conducts a pressure test at the site that designer has to be designed. It is also important to be aware of the diameter and height of the main pipe. Design criteria for the head losses is the last one. Head losses making the assumption friction losses is adequate. To compensate for a little losses, we can use the corresponding pipe length in their design calculations. A loss through an equal length of the straight pipe can be used to explain small losses such as flow via valve and fitting. This project allows us to use the Hazen-Williams formula to calculate head losses. Here is the formula to calculate the head loss, whereby L is the effective length, D is diameter of pipe, Q is the flow rate in the pipe, C is the Hazen-Williams pipe roughness coefficient. Next, we are moved to design analysis. First thing first, we have to do the layout pipe flow. The pipes are places such that the water is delivered to each industrial sector. The pipes are put below the road in front of each industrial unit in this project. The sort of a structure and the quantity of the building are known before the drawing are created. Here is the layout plan for pipe flow that I managed to design. Here is the layout numbering for node and the pipe. In this project, we have a 30 node and 42 pipes. And also in this project, I decided to use by loop because it will be more easy for us to use the IPANET for run the analysis later. Here is the calculation for water demand. To be specific is the average flow. I will take one example from the loop 1, which is the industrial ringan cluster. The water demand is 33,000 that I get from the SPAN, Suruhanjaya Perkhidmatan Air Negara, and the unit is liter per hectare, and the quantity is 36, which means the quantity in the loop 1 industrial ringan cluster have a 36 unit, and the total area is 34,479 meters square. And will be convert to hectare is 3.448 hectare, and the total demand is 113,781 liter per second, and the average flow is 1.317 liter per second. And then for the all of average flow in this project, we have 10.312 liter per second. Next, design analysis for a calculation of peak flow. I will take the one example from the number of loop 2, which is industry perkhidmatan cluster. The average flow is 0.176 that we need to times 2.5, and then we get a 0.440 for the peak flow rate. And the total peak flow rate in this project is 25.781 liter per second. Here is the design analysis for the calculation of fire flow. For the fire flow rate, actually all of these are same except of in the loop 10, which is in the loop 10 have the node that are removed from the node 1, which is the value of average flow 0.085 must be plus with 22.348, and then equal is 22.469 liter per second. And the total for fire flow in this project is 32.696 liter per second. Here is the design analysis for layout balancing for base demand. This layout I get from the EPANET software, and the value show here is the all of the base demand is lower than 25. Here is the layout balancing for flow rate. And also this layout I get from the EPANET software, and the value show here is a range from 25 to 50 is the quite lesser than the value that show the range of 0 until 25. Here is the result from EPANET. In this EPANET, we have to put the length of pipe, diameter and pipe, and in this project I decided to use all of the pipe is only 150 mm. And the length pipe I get from the AutoCAD software. And the main reason we use the EPANET software is to get to know the head and the pressure, and also the velocity and the head loss in the each of pipe. Next, we are moved to a water tank design. In this project, we use a Bernoulli equation. Here is the equation that H naught is equal to 0. This is because of the fluid surface. Z naught is the elevation of the bottom water level. H1 is the final satisfactory pressure head at knot 1. Z1 is the elevation of knot 1 from datum. L is the pipe length. D is the diameter of pipe. Q is the flow rate supplying to the knot 1. Here is the calculation to get a bottom water level. The pipe length is 11.293 meter, the pipe diameter is 0.15 meter, and the final satisfactory pressure head of knot 1 is 22.66 meter, elevation of knot 1 is 61 meter, flow rate at peak flow is 25.781 liter per second, and the Hazen-Williams coefficient is 130. And the total of bottom water level is 83.84 meter. Here is the calculation to get a top water level. Top water level of the surface in the elevated water tank is equal to bottom water level plus with the water tank height. The top water level is 83.84 plus 5 is equal to 88.84 meter. Here is the proposed size of water tank. The diameter that we are proposed is 22 meter and the height is 5 meter. Total water demand in this project is 10.312 liter per second. Then we are convert to liter per day. We get 891,235, and then we are convert to meter cube. We get the 891 meter cube. The volume of this water tank is 1,900 meter cube, which is greater than the total of water demand, which is 891 meter cube. So the proposed size of water tank is accepted. Here is the layout plan for our proposed size of water tank design. Here is the last part, which is conclusion. The water reticulation system can be defined as the system of pipe made which control for the household or industrial which used to treat the water system. The best suitable pipe diameter for each pipe is determined to be 150 mm to the design program EPANET. Since my steel pipe has a high tensile strength and is also reasonable price, we decided to use it for our project to carry water from knot to knot. To satisfy the whole demand for the envisioned residential development, we recommended using an elevated water tank with a 22 meter diameter and 5 meter of height, to guarantee that the water supply to each premises has an acceptable head of pressure. The water tank is installed at the high proposed level for our project site. Thanks for watching. I'm Akmal Shukri from Designology Company from Group 18. Thank you.